In this video, I want to have a look at tangents and normals. So the derivative of a function at a point P tells us the gradient of the tangent at that point. So in our little diagram here, if this is our point P, then we're finding the gradient of that pink line there. So from that, if we know the gradient of that pink line and we know a point that it passes through, we can actually find the equation of that line using the formula y minus y1 equals m outside of x minus x1, where our point is our x1, y1, and our m is our gradient. So let's have a look at an example. So our question asks us to find the equation of the tangent to the curve f of x equals 2x cubed plus 5x plus 3 at the point 1, 10. So that point lies on our curve. So the first thing we're going to do is we're going to differentiate this so that we can find the gradient at that point. So if f of x is that, then f dash of x, so our derivative, is going to be equal to 6x squared plus 5. So that's the gradient function, but to find the derivative or the gradient at the point 110, we're going to substitute in that 1 for x. So f dash 1, the gradient at that point, would be 6 times 1 squared plus 5, which will give us 11. So this is the gradient we need in that formula. Our y minus y1 equals m outside of x minus x1. And this point up here is our x1, y1. So if we put in all of that information, we're going to have y minus 10 equals 11 outside of x minus 1. And then we'll expand this side out. So we'll have y minus 10 equals 11x minus 11. And then we'll just rearrange it to make y the subject, and we'll have y equals 11x minus 1. So that there is the equation of the tangent to this curve at that point. So next we want to have a look at normals. So a normal is a straight line that passes through a point on the curve that's perpendicular to the tangent. So if we've got our tangent drawn there in grey through this point, then our normal passes through the same point and it's perpendicular, so it makes a right angle with that tangent. So let's have a look at another problem involving a normal. So this one asks us to find the equation of the normal to the curve f of x equals 3x squared plus 8x plus 6 at the point minus 2, 2. So the working out for this question is going to be very similar to our last example, but there's just one extra step in there. So we're going to find the derivative first. So f dash x is going to be equal to 6x plus 8. Now at the point minus 2, 2, so we're going to find f dash minus 2. So we'd have 6 times minus 2 plus 8. So that's minus 12 plus 8 would give us minus 4. But this is the gradient to the tangent. We want the gradient of the normal. So the normal is perpendicular. So if this gradient is minus 4, then the gradient of our normal would be 1/4, because we need m2 to equal minus 1 over m1, which would be minus 1 over minus 4, which will give us 1/4. So that's because that's the relationship that our two gradients need to have for them to be perpendicular. All right, so this is our gradient and these are our x1, y1. So we'll put them in this equation again. So we've got y minus y1 equals m outside of x minus x1. So we're going to have y minus 2 equals 1/4 outside of x minus minus 2. Now I don't usually like working with fractions. Let's multiply both sides of that equation by 4. So we'll have 4y minus 8 equals, and if we multiply this by 4, that 1/4 just becomes 1. So we're just going to be left with what's inside the brackets, which is x plus 2. Now rather than rearranging this into gradient intercept form, let's just put this in general form because our y has a coefficient that's other than 1. So our x is positive, we'll bring everything over there. And we'll end up with x minus 4y minus 6. Right, so that's the equation of the normal to the curve at that point.